Alright, so let's solve this interesting LeetCode problem today, which is longest repeating character replacement. It says you are given a string s and an integer k. You can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most k times. Return the length of the longest substring containing the same letter you can get after performing the above operations. If we check example 1, our string is A, B, A, B. So if we swap these two B's with A, the longest substring with the same character we can get is A, which is 4. You can also swap the two B's, the two A's to B's anyhow. Let's move over to the whiteboard and try to understand how we solve this problem. Alright, I have our two examples here. And to solve this problem, we are going to use like a sliding window approach. Now, take for instance, we have a window of size 4. Now, for this window, the number of characters we can replace is simply the length of the window, let's call it L, minus the maximum character frequency in this window, which is 2, because A appeared 2 times and B also appeared 2 times. So, making it 4 minus 2, which is 2, meaning we can replace 2 characters here that are not the maximum character. So we can replace B and B to A, which gives us the answer as 4 now for this. Let's understand better with the second example. So now if we have a window size and we keep shifting up to this index, now our window size is 4. How many characters can we replace here? The number of characters we can replace here is simply the extra size remaining, the extra space remaining when we minus the maximum character from this window. In this window now, the maximum character is A and the frequency is 3. So if we minus 3 from the length, it tells us that we can replace 1 character in that window, and we are still valid because k is 1 is equal to k. So let's take for instance we shift our window to this side B now. Now the maximum character frequency we can get from here is simply the length of the window, which is 5 minus what is the maximum character frequency in this window? It's still A, and A is 3. Meaning if we subtract 3 from the length of the window, we have 2 extra spaces that we can replace the remaining values. Now 2 is greater than 1, making this size not to be valid. So if you try to do the same thing and reach the end of the array, you find out that the maximum length we can get in this example is 4. I hope that makes sense. Let's try to write the code now. Alright, so the first thing we're going to do now is to initialize a variable which will keep track of the maximum valid length. And finally, we initialize a hash table which will keep track of the items in our window. So we can call it. And then another variable which will track the frequency of the maximum character frequency in this window. Now our left and right pointers, which will all be 0. Now we want to iterate while arrow is less than length of s. We add the item at the character at s to our window. Character at r, sorry. And then we update our maximum character frequency to be the maximum between itself and the new item you just added. The frequency of the new item you just added. And then we calculate the remaining space left after subtracting the maximum character frequency from the from our window length. So we can do capacity. Let's call this capacity. Window length is basically r minus l plus 1 minus the maximum character frequency. And then we check if capacity is greater than k. We have more characters to replace, so it's not valid. We can simply shrink our window. First, decrement the frequency for the character at the left index. And shrink our window. And then update our max length because now it's valid. And our window length, which is, and then increment our R, and finally return max length. Alright guys, so the code works, and that is it for this video. See you all on the next one.